What up? Talking about adding rational expressions, which also means adding fractions. Which you're like, wait a minute, but we've done that already. Why do we have to learn more? Well, guess what? We now got to deal with variables as well. And, well, you're lucky because not as much of a factoring is involved here. And when you get to the next course, it'll be the same thing, but factoring. All right. So again, adding fractions, we need what? So need, wow, that is the ugliest need ever. All right. Need common denominator. Okay. So in order for us to add or subtract, we need common denominators. Okay. All right. So let's jump right into examples. And since we just talked about doing how to do least common denominators in that last session, let's go right into examples. So the first example I'm going to put up is this. 7 over, I'm going to put it right into colors right away, 4z cubed plus 1 over 14z squared. Okay? So, again, I need common denominators. So only the bottom matters right now to get the common denominator. So if I broke down the 4z cubed, I have a 2 times 2, a z times z times z. Okay? And if I broke down the 14, I'm going to have a 2 times 7 with a z times z. Okay? So I'll look at the two bags. Again, what do they have that I don't have? Well, let me see. They have a 7 that I don't have. And that's about it. Okie dokie. So now this dude moves over here and says, hey, what do they have that I don't have? Right? They're like, well, you're missing a 2 here and you're missing another z. Right? So now if I look at the two bags, the green bag and the the green bag and the blue bag, I'm going to have the same number of 2, same number of 7, same number of z's. Okay? So with the green, I have to, since the 7's in red here, that's what's missing, so I got to multiply by 7. If I do it to the bottom, I got to do it to the top. On the blue, what was missing? It was missing a 2z. So I got to multiply the bottom by 2z. So that means I got to multiply the top by 2z. Okay? So from there, I can go, okay. So let's look at the first fraction. The first fraction, 7 times 7 is 49. And the bottom is 4 times 7, which is 28. Z cubed plus. The top is 1 times 2. And then z over 14 times 2. And then z squared times z is z cubed. Awesome. Look, I now have common denominators. So I keep the bottom. And then add or subtract the top. The question is, can 49 and 2z add? And the answer is no. They're not like terms. So wow, we're bringing back like terms of adding, subtracting polynomials too. Whoa, dude. So we have 49 plus 2z. And ladies and gentlemen, that is going to be my answer. Yes, it looks way more complex than the original, but that would be my answer. And I can't reduce anything because there's no GCF on top to be pulled out to reduce the number on the bottom. So a couple of notes here. Notice that there is an addition sign right in here, right? The addition sign basically bonds that binomial together. So I cannot go, well, I can reduce the 28 with a 2 and make this a 14. I can reduce the z. I can't do that, okay? That's like almost saying that I'm going to someone's house and stealing something from that house, or you can call it a home wrecker if you want to, but essentially that's the same idea, okay? So I would tell you, don't do any of that. If it has addition sign, leave it alone unless you can pull a GCF out to reduce. Other than that, you can't break up that addition or subtraction sign, okay? All right, let's get to a next example. Okay, this one is going to be a z plus t over zt squared plus 9z plus t. Ooh, looks like I have a leaky pen, but I can't. Okay, over z squared t. I forgot to make those different colors. Let's make a green and this one blue. All right, so let's look at the green again. That is a z and a t. And then the blue is a z with a t. Okay, so I'm looking at the two bags saying, what do they have that I don't have? Well, the green is missing a z. The blue is missing a t. If I look at the two bags, they both have two z's and both have two t's. So what is the green denominator missing? It's missing a z. So if I do it to the bottom, I gotta do it to the top. Whoa, don't forget that. And this one is missing a t. So same thing, I will multiply this by t. So what happens? Well, the reason why I put the parentheses around is because the binomial z plus t is actually a number, right? So if I said 2 times 32, right? I would do 2 times 32. I wouldn't do 2 times 3 and call this a 60 and then leave the 2 alone and not multiply that, because that's not true. That doesn't equal, right? Or think about this. Back in the day, you'll be like, okay, 2 times 2 is 4, 2 times 3 is 6, so there's my answer, right? You multiplied to both things, all right? So this is essentially talking the same thing. So that binomial is actually a number, so this z actually has to be distributed. This t has to be distributed. So my top is actually going to be a z squared plus, I'm going to say zt, and then the bottom is going to be a z squared t squared plus, over here, the top is going to be a 9zt plus a t squared over z squared t squared. Now look at that. The bottom is the same. Woohoo! So I got z squared, t squared, and the top is going to be, oh, look at that. Aren't these like terms? zt and zt. So I got z squared plus 10zt plus t squared. And that would be my answer. And if your question is like, how the heck did you get 10? Well, don't forget, guys, there's an imaginary 1 right in front of there, so 1 plus 9 would be 10, okay? And that's about as hard as it gets. If you have any questions, let me know. Later.